We'll move on to functions now. Function basically is a relation. Okay, we have been doing relations. So function basically is a relation. What you have done in lower classes is, if I ask you what is a function, probably you will say that any expression which involves a variable is a function of that variable. I'll write that anyway. Can you see? Yes. Any expression. This is not the definition of functions, mind you, as such. I'm just trying to relate to what you already know, okay? Any expression involving a variable is generally, according to you, is a function. Can you see? Yes, is a function of that variable. For example, you have done expressions like x squared plus x plus 1. Generally, you write it as f of x. It is a function of x, like this, isn't it? Then if you come across, say, x square y square plus x plus y plus 1, this is actually a function of x and y. This is what you have done in your lower classes. You have, generally we denote it by y. So y is equal to fx. This is an expression, suppose. That is, you can have y is equal to, suppose, the first one, x square plus x plus 1. The expression is given by this, and symbolically we write it as y is equal to fx, which signifies that is a function of x, where x is your independent variable, y is your dependent variable, because x can take up any value that we want and y will be a value which depends on the value of x. So this is what you have done earlier, but now you cannot stick to this. You have to, the concept is actually much more than what you have learned. What is the definition of functions? That is what is most important. Okay, what is the definition? Suppose A and B are two non-empty sets. Okay, non-empty sets. A and B are two non-empty sets. A function f is basically a relation from A to B. When will it be a function? If that relation satisfies a certain criteria. What is the criteria? If for, this is important, every element x, suppose, of the set A, there exists, this is the symbol for there exists, I hope you know it, there exists, or I think I'll write there exists below because it won't fit over there. There exists, okay, there, inverted E, there exists a unique value element. There exists a unique value y belonging to B, such that the pair xy is related to each other by the function that is defined. Okay, so this is the most important part. For every element of A, there exists a unique value y belonging to B. If this criteria is satisfied, only then it will be considered a function. Okay, now what do you mean by this? Let us take up a few situations. Suppose I'm drawing it in the form of an arrow diagram. That will be easier to understand. Okay, so you have a set A and you have a set B. Okay, set A, suppose, has elements 1, 2, 3, 4. Okay, 1, 2, 3, 4. And set B has elements, what shall I take? 2, 4, 6. So 1 is related to 2. What is the function over here? If you notice, y is equal to 2x, isn't it? 2 is twice of 1, 4 is twice of 2, 6 is twice of 3. So y is 2x, or you can just simply write f is equal to 2x. Okay, same thing, f is equal to 2x. You can write this also. F means fx. Okay, so look at this. So what are the pairs of elements that I have? If I write it in listed form, then the pairs are 1, 2, right? Then you have 2, 4, and you have 3, 6. 1, 2, 2, 4, and 3, 6, where the domain, this is the domain, I hope you remember, right? This is the domain and this is your codomain. I'll write on top of it itself, doesn't matter. So A is the set 1, 2, 3. A is the set 1, 2, 3, 4. Okay. So notice something is happening. What is happening? What did I say in the definition? Every element of the first set, this is what? This is the domain, isn't it? X belongs to A is the domain. Every element belonging to the domain must have a unique element belonging to the codomain. That means, notice what is happening. 4 is there in the first set which does not have a corresponding value of y. That means this is the value of x. There exists a value x in the first set which does not have a corresponding value of y. Therefore, this is not to be considered as a function. Okay, so that is why I put a cross. So this is not to be considered a function. Why? Because there is one element left over in the first set. I'll write the reason. Since 4 belongs to A, does not have a y belonging to B. The element 4 belonging to the first set A does not have an element y belonging to the set B. Set A is called the domain of the function, just like domain of relations, and B is called the codomain of the function or the relation. Okay, so this is definitely not a function because it does not satisfy the criteria of a function. Okay, another situation can arise. For example, you have sets A and B as usual. I will draw over here. This is your set A having the elements 1, 2, and 3. And you have the set B having the elements A, suppose, B, C, and D. 4 elements are here. And there is a function between a relation from 1 to A, whatever it may be, whatever the expression may be, we are not concerned with that right now. And 1 is also having a value B, 2 is having the value C, 3 is giving me the value D. Suppose this is the situation. So if I write it in listed form, then what is actually the set? The relation, it is 1A, 1B, 2C, and 3D. Here notice A, the domain is 1, 2, 3. All the elements are being used up. So the first condition is fulfilled. What is the first condition? That for every element A, X belonging to the set A, there must be a unique value Y belonging to the set B. Okay. So that criteria is, the first criteria is fulfilled, that every element has been utilized. Okay, now the second criteria, there exists a unique value of y. Unique value means what? Only one value of y. Okay, for one value of x, you will get one value of y. This is the meaning. For one value of x, there should be one value of y. This is what is needed actually, according to definition of function. In other words, for the same first component, there cannot be two values of the second component. Okay, for the same first component, there cannot be two values of the second component, because notice here, first component is A, but second component I have two. One is A and one is B. So this is the problem over here created by 1A and 1B. Here first component is the same, but there are two values of the second component. That means what is happening? So it is not fulfilling the condition of uniqueness. It is not fulfilling a condition of uniqueness. Therefore, this is also not a function. Okay, so this is also not a function because we are not getting a single value of y for a single value of x. Okay, for every value of x, there should be only one value of y. There cannot be two values of y. There, okay. So this is another situation where this relation will not be considered a function. Suppose we have a situation like this where there's the domain having the elements 1, 2, 3, 4 and the codomain is having the elements A, B, C, D, E such that A is giving me, 1 is giving me A, 2 is also giving me A, okay, 3 is suppose B, no problem with that, okay, 4 is suppose D, okay, and what else? What about 3? Shall we take another one? 3 I've taken with B. 3 I could have taken with C also. I'll do one thing. 4 I will do with D again. No, sorry, there's no 4 over here. 4 shall I take with another one? 4 with C. Okay, 4 with C. That will be better. Suppose. Okay, I could have left it as it is also. Anyway, doesn't matter. So if I list actually what am I getting? I'm getting the pair 1A, 1 giving me A, 2 giving me A also, 3 giving me B, 4 giving me C and 4 giving me D also. Okay. So here notice this is not a problem because for 1 I am getting A. For 2 I am getting A. A is a separate value, isn't it? So second components may be the same, but the first components is not same. So this is definitely a function. Moreover, all the elements of A is utilized. The set B can have elements left over, doesn't matter. Actually, B is the codomain. If I list, B is the codomain consisting of the elements A, B, C, D, E for this function. Whereas if I write only range of this function, then it will be only the values of y that I am getting for a value of x, that is A, B, C, D only. Okay, so this is what I am getting. So basically over here what is happening is range is a subset of the codomain. Note, in this particular case range is a subset of codomain. So no problem with that, that is allowed. Okay, and moreover we can have elements in codomain left over, doesn't matter, but two criteria, basic criteria of the definition that must be fulfilled is that every element of the domain must be utilized to get the values of y or the range. Okay, and range can be the same as codomain or range can be a subset of codomain. That is not important. What is important is that every element of x should not should give me only one value of y. So this is allowed. In fact, notice something here. What is happening? This is diverging. So if you come across a divergence, it is not a function. Whereas here what is happening? Here it is converging from here. Another. No, wait, I made a mistake over here. Sorry, I made a mistake over here. 4 cannot be. 4 is repeated twice. No, first component is repeated twice, so I cannot take this. Sorry, children. This is 4D over here only. So actually, C is not mapped and E is also not mapped. A, B, D only we have as the A, B, C, D, E is your codomain, whereas the range is A, B and D. Sorry, okay. So therefore, you can see that this is a mapping because it is converging. Okay, so therefore if you come across convergence, then it is definitely mapping of function. Mapping of function is the same. We'll do that in class 12 later on, more details. Okay, so please remember this. That is, in fact, this has a name also. This is a many one. From many, you are getting one value. So this is a many one function or a many one mapping. Whereas you have one-to-one correspondence also. This is actually a many one function or a many one mapping. Similarly, you can have one-one function as well, but one many is not possible. Here it is, notice this is one which has been giving me many values, so this is one many. So one many function or one many mapping is not possible, whereas many one is possible. So there are two types of functions basically. One is your one function, one function, and the other one is many one function. In fact, if we deal with functions as a mapping, then we'll have more subparts: onto function and into function, or onto mapping and into mapping. That right now you don't have to do. We'll do that in details in class 12. So this is what you need now. And one more term you must be familiar with, that is images and pre-images. I hope you're familiar with that. Many one we have drawn already. I think I'll draw one for one also. As the name suggests, obviously, this is your set A, this is your set B. Here are suppose 3 of them, here are suppose 4 of them. So it's from A to B, from one element of A to one element of B, from one element of A to one element of B. So this is your one correspondence or one function or one mapping. For every x, you are getting only one value of y. Whereas here, what is happening? For every x, you can get two values of y, two or more. I've taken 2 here. So for every x, there can be two values of y. So this is a many one function or many one mapping. Now basically what you have to do over here in this chapter is finding the domain, range, codomain and all that. And be familiar with the terms, that is the second components, okay, or you can say the range of the function f, okay. They are said to be the images. They are said to be images of the first components. Be familiar with this term, okay. The second components, that is y, which belongs to B, are supposed to be images of the first components of the domain, okay. That means elements of the domain, I think I'll write that in words. Elements of range are the images of elements of domain. They are said to be the images of the elements of domain, whereas elements of the domain, I'll write it, on the other hand, the first components, that is x belonging to the domain, okay, they are said to be elements of domain. I won't write that. They are said to be pre-images of the second components y belonging to the set P, okay. In other words, be familiar with this term also, okay. In other words, elements of what do you call it, domain are the pre-images of elements of the range, okay. Elements of the domain are the pre-images of elements of the range. This is the term used for those elements. The first components, alternative term, first components and the second component. So basically, you will be asked to find, okay, the domain of a function or the range of a function, or you can say they are the images and pre-images of the function. So images are basically the values of y, okay, which are obtained from the given values of x, okay, and pre-images are the values of x such that elements of domain x belonging to A. Oh, I think I've written here. Okay, never mind. First components, I've written already, so no need to write here. Okay, so first components are said to be the pre-images of A. In other words, x belonging to A are pre-images of y belonging to B if y is a function of x. Otherwise, they won't be a part of the range, isn't it? So therefore, this also you should keep in mind that x belonging to A will be the first components or the pre-images. I hope you can see. Is it too light? I don't think so. Anyway, are the pre-images of y belonging to B if y is equal to fx. If it satisfies that function that is given over there, only then it will be a part of the range, and therefore this is what you have to remember and apply. So we move on to numericals now.